Okay, so today we're going to look at 6.5, which is determinants of matrices. So really, to find inverses, which is what we did in 6.4, you had to find the determinant. So you've at least done so with a 2 by 2. So if we're looking at a 2 by 2 matrix, we'll call it matrix A. Let's say A, B, C, and D. Matrix A, B, C, and D. The determinant, a lot of times they'll either denote it with DET of A, or they may use what looks like an absolute value, which also means determinant. If you're pulling up in your calculator, they're under matrix equations or calculations, sorry, it's going to use the DET. So for what the determinant is just we multiply down the diagonals and subtract. So again, that's what we did. So the first thing we did to find our inverses. So that's pretty simply what a determinant of a 2 by 2 would be. So an example would be, say I had 12, 3, 2, negative 3. And I want to find the determinant of that. So what I'm going to do is to multiply here. It's going to give me a negative 36. So we multiply the 12 times the negative 3. Now we're going to subtract and multiply the 2 times the 3. So it's going to give me a 6. So it's a negative 42 is that determinant. Okay, so if we want to find the inverse, we'd use that. Now we can also use this to solve for a linear equation or system of linear equations. So say I have 12x plus 3y equals 15, and 2x minus 3y equals 13. Okay, so we've talked about solving these by substitution, by elimination. We've talked about solving these using Gaussian elimination, which you didn't like apparently. But we can also use what we call Cramer's rule. So we've got lots of different options on how we can solve these. So Cramer's rule. So to use Cramer's rule, we're going to use determinants. So what we're going to do is find the determinant of our coefficients. Okay? So we're going to find the determinant of coefficients. Which actually, if you notice, we've already done this one. Okay? So multiply this diagonal, and we'd get 42. Negative 42. Okay, now to find our x value, what we're going to do is make a determinant, but instead of using my x's in my first row, I'm going to use my solutions over here. So we've got 15, 13. Go ahead and use my y column. 3, negative 3, and I'm going to divide by my coefficient determinant, so by negative 42. So here we're going to do our determinant, so I've got 15 times negative 3 is negative 45, minus 3 times 13 is negative 39, and I'm going to divide by negative 42. Okay, so negative 45 minus 39, what does that give me? 84. So I've got a negative 84, divide by negative 42, and I get a 2. So my x value is 2. Now for my y value, we're going to do the exact same thing, except now we're going to put our solutions in my y column. So I'm going to leave my x column the way it is. So I have 12, 2. My y column is going to be 15, 13. And I'm going to divide by negative 42 again. So now I've got 12 times 13, which is 156. 15 times 2 is 30 over negative 42. So 156 minus 30 is going to give me 126 over negative 42, which gives me negative 3. So my solution to this would be 2, negative 3, using Cramer's rule. So again, it's just a different rule to do what we've kind of done before. So let's do one more of those. let me get a piece of paper. So say I have, so say I have 2x equals 3y plus 2. And then I've got a 5x equals 51 minus 4y. Okay, so the first thing we need to do is get our x's and y's on the same side. So we've got to have our x column. I'm going to move that 3y over, my y column, and then my solutions. Okay, I'm going to move my 4y over. So I've got 5x plus 4y equals 51. Okay, so now the first thing we're going to do is find a determinant for our coefficients. So I've got 2, -3, 5, 4. Okay, so 2 times 4 is 8. Minus 5 times 3 is -15, so it's going to give me a plus. So 8 plus 15 is 23. Alright, so now for x, we're going to let our solutions replace our x's. So I've got 2, 51, and -3, 4. And I'm going to divide by my coefficient matrix. So I've got 2 times 4 is 8. 51 times -3 is going to make that a positive 153. So 8 plus 153 is 1.